So, we went through all this work to come up with a general version of summation, and we used it to sum natural numbers and cubes. But what about the summation of those terms that converge to pi? Well, let's do that too, interactively. From operator, import mul. Step 2 will define a function that computes each term of the sequence that converges to pi. So let's call it a pi term, which is a function of k and returns 8 divided by 4 times k minus 3 and 4 times k minus 1. So we call summation. Let's sum a million terms of these pi terms, and what do we get? 3.14159, and then it's wrong. It's an approximation, but it got us pretty close. Okay, one more example for the day. We're done with this. We'll clear this out. I'm going to show you how to define a function that returns a function as a value. This will be called makeAdder. Takes an argument, which is a number. We'll call it n. And it's going to return a function. This function will take one argument, we'll call it k, and return k plus n. So what does that mean? That means we can create new functions on the fly. Like we'll create one called add3, which we'll get by calling makeAdder on the number 3. Once I have this function add3, I can call it on some other argument, such as 4, and it will add 3 and 4 together to get 7. So part of this function that we create called add3 is that it remembers that 3 was the thing that it adds. Now how do we define this? Well, we define adder, a function with formal parameter k, which returns k plus n, just as I said in the docstring. Now, let me tell you the structure of this. We have one def statement here, which within it has another def statement. Now this return line is part of the body of adder, whereas this return line, as you can see, is part of the body of makeAdder. So makeAdder returns a function. Adder just returns a number. And the interesting thing is that adder can use names that are its formal parameter and the formal parameter of makeAdder, the surrounding function. So that was an example of functions as return values. When a function is defined within another function's body, and the function that's created is bound to a name in the local frame. So here's the code for makeAdder, which we just saw. makeAdder is a function that returns a function. In the doc test that I wrote, add3 was bound to that function that was returned. Now we have a local def statement here, def adder k, which can refer to names in the enclosing function. So n is bound here, k is bound here, and both k and n are available in the body of adder. What happens if I type something like makeAdder1, 2? These spaces are just here as extra space. Well, what you're looking at now is a call expression with an operator that's also a call expression, and an operand, which is just a numeral. So an operator is any expression that evaluates to a function, which is exactly what we get back from makeAdder. And an operand is an expression that can evaluate to anything. So how do we evaluate this? Well, we evaluate the operator, which is a call expression, which means we have to evaluate its operator, getting our makeAdder function, its operand, giving us 1, and then we call makeAdder on 1. And what we get back is the adder function. So we have the adder function available to us. what's it going to be called on? That's 2. So this adder function is going to add together 1 and 2 to give us a value of 3. So let's see this in action. Python 3-i x.py make adder 1, 2 gives us 3. Make adder 2013 gives us 2013, but I can also do this in 2 separate steps. So I can say make adder 2000. Now I have a function which I can call on 13. So what's the point of all this? Well, first of all, we've shown that functions are first-class values, meaning they can be passed as arguments, they can be returned as return values, just like any other value in our programming language. A higher order function is a function that does these things, takes another function as an argument, or returns a function. Now, higher order functions are useful because they can express general methods of computation, how to sum things together, without worrying about what I'm summing together. They remove repetition from our programs because we only needed to define the act of summation once. Finally, we can separate concerns among functions. We want each function to have exactly one job. And having higher order functions allows those jobs to be very general methods of computation, or their functions which they take as arguments or return as values can be much more specific.